hello everyone. This is our level 4 group, I think. Do we know if anyone else is coming, Carlene? Hi, Misty. Do we know if anyone else is coming or?
Is Caspian going to be in this room this week? Annalise?
I'm not sure. What class are you in? Are you sure? He says he's in here. But
Oh, okay. He's coming then. So yeah, Caspian, but waiting on Miss Westbrook to make sure he gets into the right room. Okay, I'll let you guys get started without me being in the room.
All right, so I guess we can just read the directions first. Carlene, if you could help us do that.
Yeah, so this one is pretty much about expressions and equations. So the directions say that each box represents a single digit according to the guidelines for each problem. Many of the equations and inequalities have more than one solution. So we're gonna see if we can find one, if not maybe two or three on the process. And yeah, let's get to it, guys.
So the first, mute yourself. So the first step, if we don't know how to do anything, we can just plug and guess. Wait, plug and check, yeah. So we can start off putting 1 in the first box, 2 in the second box, 3, and then 4. And does anyone have any ideas on how to solve this equation? No? Okay, so the first step on solving this equation is moving all of the x's to one side and all of the numbers to the other side. So we can subtract 1x from both sides. So we'll get 2 equals 2x plus 4. And then we have to subtract all of the numbers to the other side. So we get negative 2 equals 2x. And what do we do now?
I think we divide by 2.
Okay, we divide by 2. Why do we divide by 2? Well, we divide by 2 to get x by itself. So x equals negative 1. And is negative 1 less than 0? Yes, so that's one solution.
Okay, so that was just like the example. So now we can move on to like some more problems. So number 2 is like, for some reason, it's kind of harder than number 3 and 4. So number 2, let's just try it out and see how it goes. So I want you guys to just start trying to fill out these boxes to make equations with a solution of x equals 2. And there's 2 boxes here because we're making 2-digit numbers. So like, for example, 53, like 34, something like that. We're going to be doing 2-digit numbers and trying to have a solution with x equals 2. So if anyone like finds a cool solution, could you just share it with us? Okay, I see Annalise says she's lost. So let's see what we can do for this one. So we know that we're going to be using the digits 1 to 9 one time each in like these boxes. So at the end, we're going to be using 8 digits. And that's what really makes this question kind of hard because, like, I don't know, there's not that many options. So the way I liked thinking about this problem was just like, you think of like a good way to make 2. So obviously, let's see, let's just fill in these numbers with like random blank letters at first. So if we move like everything to one side, this is what we're going to get. And then we see at the end, we're going to be doing like a division type thing. So like we're going to be dividing something by something to get 2, since we want x to be equal to 2, right? So what I started doing was I just started listing out ways to make 2 division. So the most obvious one is going to be 2 divided by 1. But the problem here is that we can never actually make the number 1, because if we want to make 1, we'll have to do like 55 minus 54 or 53 minus 52. But we know that we can't use the same number twice. So then like we can move up 1. Let's try 4 divided by 2. And I think you can make one solution using 4 divided by 2. So like we're going to have a 2-digit number here minus a 2-digit number here divided by a 2-digit number here minus a 2-digit number here. And I think the best way to do this is by just writing out all the numbers to see the options you have. And to make, wow, chocolate chip ice cream. To make 2, the best thing that I thought of was using 9 and 1, since these are like edge numbers that like you probably won't really use for anything else. So if we're doing that, then we like, I don't know, we can just choose 2 numbers from the middle, like 5 and 6. And so the best way to make 2 from these numbers is just going to be, let's see, that's a big eraser. 50 or 61 minus 59. So that gives us our 2, and then at the top we still need our 4. And to get the 4, I think, do you guys see a way to get 4? Because I'm pretty sure there's one here. Just think of like a high of 1. Wait, I don't know how to explain this. A high like 30s and like a low 40s, I think. That might give us 4. Okay, Annalise says 42 minus 38. So that's really good because we haven't used 4, 2, 3, or 8. And 42 minus 38 is indeed 4. So now we can kind of like, I don't know, work backwards, I guess. And this equation does give us 2 because it's going to be 4 divided by 2. So we know that this does give us a solution of 2. So let's just work backwards and see like how we're going to fill out the boxes. So we can multiply this entire thing to the other side to get 61 minus 59 all times x is equal to 42 minus 38. And then we can distribute our x thingy to get 61x minus 59x is equal to 42 minus 38. And then once we like do our additions, this should give us a pretty nice answer. And that's like one of the solutions for this problem. 6, 1, 3, 8, 5, 9, 4, 2. And so yeah, that one works. But like I said, number 2 is like kind of hard compared to some of the other ones. So I think we should try out like number 3 maybe. So number 3, again, we have to make an equation with one solution. But the difference here is that we only have 4 boxes. So it's like a little less options. I think that makes it easier. So you guys could try out this one. Just remember, we have a digit in each box. They have to be different. And in the end, we want x to equal -1/2.
Also, does anybody have any questions about number 2 while they're at it? How that worked? If not, then you can go ahead and try number 3.
If you guys need another hint, I think the best way to approach these problems is by first sticking in a bunch of variables. And then when we solve for x, we're going to get an expression that's like x is equal to d minus b over a minus c. And then using this expression, we try to make, we start like from back and like work forwards, kind of like that. That's how I like thinking about these problems.
All right. Caspian, Annalise, anybody got any ideas? Or Benjamin as well?
All right, so do you guys like understand how I got to this part where x is equal to this stuff? Okay, so let's start from the beginning. So we know that we have some digits that we don't know, and because we don't know them, let's just use letters for them. So A, B, C, and D are going to be our digits. And we're just like pretending that these variables are numbers. So to solve for x, because x is like the only thing we actually care about, we have to move all of the x terms on one side and all of the not x terms on the other side. So if we subtract by cx on both sides, we'll be left with ax minus cx plus b is equal to d. And then remember, we also have to move all of our non-x terms to the other side. So if we're subtracting b on both sides, we'll get left with ax minus cx is equal to d minus b. And here we have two like thingies, two terms, both with the x. So we can like factor out an x. Do you guys know how that works? So like if there's, say, 3x minus 2x, that's the same thing as here. It's the same thing as x times 3 minus 2. Yeah. So it's the same idea over here, right? Ax minus cx. If a and c are numbers, we can take out the x and just do like a minus c on the inside. Are we cool with that? And then on the other side, we can just leave stuff alone to get d minus b. And like at the end, we want our x, right? So we can divide by a minus c to get our x by itself. And so this is like the final little place we're at with the letters. And now we actually bring in the numbers, right? So we know that with the letters we've chosen, we're going to get an expression that kind of looks like this. And we want this expression to be equal to negative 1/2, like it says up here. And negative 1/2 can also be written as like just negative 1 divided by 2. Or you could also write like 1 divided by negative 2. It's really just whatever you want. And so we just try to pick random numbers so that the top is equal to negative 1 and the bottom is equal to 2. So can you guys give me like a pair of 2 numbers that when you subtract them, you get negative 1? Just any 2 numbers from 1 to 9. Okay, so we can do 7 minus 8. So I need to do a little bit of erasing here. We can try x is equal to 7 minus 8. Oh, that's not an 8. 7 minus 8 over, and then we still have Caspian, we can try yours in a bit too. And then we still have the bottom, which is going to be 2. So we need another 2 different numbers that are going to subtract to give us 2, right? Because at the bottom we have a minus c is going to be 2. So could you give me another 2 different numbers other than 7 and 8? Okay, so both of those work. I'll use yours, Caspian, this time. 4 minus 2 on the bottom, right? So if we simplify this, we'll get on the top negative 1 and on the bottom 2. And that does actually give us our solution of x is equal to negative 1/2. And so if we want to go backwards and fill back in the boxes, we can see that 7 is going to be our d here. So this is going to be 7. 8 is going to be our b. And then let's see, 4 is going to be a. And then 2 is going to be our c. Oh, oops. Okay. So like, this is, I don't know, just how I like thinking about it. You solve for x in the beginning, and then you have like an expression with like some variables that is equal to x, and then you set that expression equal to the number you're trying to get. And so when you're doing this, it makes it a little easier to like find numbers that add and subtract to their numbers. And then after you get a cool solution, then you move backwards and fill in the boxes. So let's see.
Hold on, Andrew. So one more time. Does anybody have questions? It makes it a lot easier if you guys understand the process to push the other harder ones.
I understand a lot better now.
Nice. What about you, Caspian or Benjamin? Okay, well, that's good. All right, so let's try a harder one. You can take it again, Andrew.
Okay, so I think slightly more difficult one is 6. So do you guys know how like an equation with infinite solutions works? Have we seen these before, or are they kind of new? Okay, so this is just going to be a real quick introduction to infinite solutions equations. So a solution with like infinite equations just means no matter what number you put in, the solution, the equation is always going to be right. So like, for example, x plus 1 is equal to x plus 1. This is an equation with infinite solutions because no matter what x we put in, we're always going to get an equation that's like correct. So basically, you want to fill in these boxes again. We can use the letters A, B, C, and D again. And we want to make an equation like this, in which like there's an infinite number of solutions. And also remember, like a key difference in this problem is that you can use the digits 2 times each. So that lets you like use the same number twice. So basically, like this solution would work if you change the 1 to like a 2. So like if you guys find a solution for this one, could you just type it out and we can check if it works?
And you don't have to think too hard about this one. It just all you would really need to do to make sure it's infinite number of solutions is to make sure that the two sides are identical. That's what it means. So like Andrew said, you can use at most 2 times each number. Anyone have any thoughts or just guesses?
Okay, I see Caspian has put in a solution. So Caspian says, we can put the x on like either number in this case. It doesn't really matter. 1x plus 2 is equal to 1x plus 2. You can see that no matter what number you put in, you always get the same thing. This equation's like always going to be true. But like we can put the x on the other number too. So because Caspian didn't really specify, we can put 1 plus 2x is equal to 1 plus 2x. And this one also works, right? Because no matter what number we put in, 1x or 1 plus 2x is always going to be the same as 1 plus 2x because they're like, you know, the same. So like these, for this question, it really doesn't matter what number you pick. As long as both sides have the same 2 numbers, you can like, it'll always work out. Okay, so let's see what Annalise says. So Annalise says we can try 2x plus 3 is equal to 3x plus 2. Okay, so let's see. If we solve for x in this case by subtracting 2x on both sides and subtracting 2 also on both sides, we'll get x is equal to 1. So the reason that we get a number here is because the order usually doesn't matter, right? But in this case, we have 2 different terms. One term has an x with it. This ax term has an x with it, and the other term has a b in it, right? Like it's just a number by itself. So we have to make sure that the term with the x is the same as the term with the x, and then the term by itself is the same with the term by itself. And then we'll be able to get like any solution we want.
You can show them how to like sum form the.
While I'm just thinking about that real quick, and at least another way to test that, if you're not sure, you know, is let's just go back to the problem we had 1x plus 2 equals 1x plus 2. You should get it to where the x's would cancel out. And so then if you're looking at problem, it's going to be 2 equals 2. So that's also like a way you can like 2 is always equal to 2. no matter what you do. Like 2 is always equal to 2. So you know that there are going to be an infinite number of solutions. So if you're not sure, just go ahead and try to solve for x, like Andrew said.
Yeah, so I see like now 2x plus 3, that works out perfectly because 2x plus 3 is equal to 2x plus 3. So I think we're about at the 9:30 mark. So Carlene, you want to like give us some ending thoughts?
Oh yeah, okay, sure. So I think the big thing here, I think Andrew mentioned it several times, is to just solve for x and see what the problem or the equation is doing. And that way you can kind of figure out, oh, if I plug in this for at this moment or at this point in the equation, then I'll get this number. So just a general approach for these questions was to solve for x with just random variables and then kind of figure out which numbers would fit best in that place. But you guys kind of got the hang of it towards the end, so that's really good.